Hey guys, how's it going today? So, if any of you get a code P340 or any of the 340s up to a certain point, chances are it's your camshaft sensor. So I've experienced two types. I'm going to talk about those two types now. One is a 2-pin, which is what I have here, and the other is a 3-pin, which is on a different vehicle that I'll try and shoot some videos for. But basically what I want to do is kind of explain quickly how they work, how to test them, how to make sure we're good. So just have a simple diagram here that I found online. I think it's a really good diagram that shows the two different types. So the 2-pin type is what's referred to as a variable reluctance sensor. So basically, think of this as your cam. And again, I shouldn't say again, but you can think of your crankshaft sensors working similarly, but not exactly. So when I say they work similar or exact, we're talking about metal that is interfacing or communicating with some type of electronic sensor. In this case, the 2-pin type is a variable reluctance sensor. What's going to happen is each time the cam or crank passes by your sensor, it's going to either generate a switch to turn it off and on, your 3-pin, which is a Hall effect sensor, which we'll get to in a second, and the other, the VR or the variable reluctance sensor, which is what I'm talking about today. So with the VR, let's talk about that one first. What happens is there's no voltage that's coming into this sensor. So you see this resistor here. It's just a voltage divider here to help smooth out some of the noise with this particular sensor. But what happens is each time this cam or reluctor swings by this magnet, it's going to turn it off and on very quickly, creating this AC sine wave. Okay? And what happens is it generates a small voltage. Typically what I've seen is 1 volt peak to peak. So that's from the very top of the signal to the very bottom of the signal. And the faster your cam spins, the shorter the duration will be of this signal. So, as it spins quicker, it gets quicker and quicker. I'm going to show you this on a scope in a second, and I'm also going to show you how to test it. Okay, so I have my setup. What we're going to do is we're going to test the VR sensor. We're going to look for this AC sine wave. Again, it's about 1 volt. This is saying 2 volts peak to peak. I've seen from 1 to 2. I'm not super concerned about that right now, unless I had a connection issue on the car. But I'm going to try and replicate how it would function in the car on a bench. So right now, what I have is a meter set up that's going to measure AC voltage. That meter is connected to an oscilloscope, which I'm going to try and show you that waveform. And then that same connection is jumped over to my camshaft sensor, which is here. So that's what you got right here. I've got my magnet. This is going to simulate your reluctance or your reluctor wheel, or possibly the flywheel on a crankshaft. Sorry, the crank on the crankshaft be your crank, not the flywheel. So what's going to happen is, as I get this magnet close, you're going to notice there's an AC voltage that's generated here. It's a small one, but you can see that each time I make not connection, but just getting close proximity, I'm generating an AC voltage. So what I'm going to do now is I'm going to zoom in on the oscilloscope and show you what that looks like on the oscilloscope. And for those of you who are wondering what setting I have on the oscilloscope, it gets kind of noisy on here, but my scale is set to 500 millivolts, and then my time base is going to be set to anywhere that you choose. I have it set at like 2 seconds right now, so that we can see this waveform in real slow time, so you can see what happens. So what's going to happen is we'll see a line that's going to come across. This is without any triggering of the camshaft sensor. Now imagine this is my camshaft, and as I go past it, as the waveform resyncs, you'll see that I'm generating a signal. So again, if I go slow, you'll see that the peaks and valleys, or the positive and negative alternations, which is what they refer to them as, actually are farther apart. Okay? So what I'm going to try and do is replicate a little faster those waveforms. So see how closer they get? And as this resyncs again, I'll lock in on this for you. So we'll stop that. You can see how these peaks and valleys are closer together. This is when the RPMs, you know, it's a higher RPM on your vehicle. Now, if I slow that down, let's say it's 600 RPMs, you'll see that those waveforms are a little bit further apart. So why is this important? Well, let's say you get a code of P340. Let's stop that. We get a code of P340, and instead of seeing a nice sine wave, you know, in a continuous stream, maybe one of these sine waves goes away. That could tell you that you get a damaged reluctor on your camshaft. So this is a way to identify if it's the reluctor, the metal ferrous material, or your camshaft sensor. All right, for those of you who can't afford a $300 oscilloscope, which is what I just showed you, and I'll post a link to that, I found this on Amazon for 30 bucks. For those of you who have worked in electronics, you know oscilloscopes can range anywhere from 100 up in the thousands. This thing's 30 bucks. It's got a rechargeable battery that you can charge with your iPhone adapter. But basically, I can take this. It's mobile. I'm going to actually simulate that same waveform on this scope. I'll post a link to this, but I think this tool is super cool. While it can't do everything a normal oscilloscope does, it gives you the ability to be mobile. So you can see each time it's actually syncing a little bit better as well. Awesome tool. So the next thing I want to do is I want to get to my Ford Taurus, and I want to take a look and see if I got a bad camshaft sensor. All right, the first test I'm going to do, assuming you don't have an oscilloscope, here's one way you can check it. So I've got a back probe. Doesn't matter which connection you use because they're both coming back into the PCM. So right now I'm just using a ground here on the battery. I have what I'm going to call my positive lead coming back to my meter, which is here. And according to Ford service information, this should be between 500 and like 2,000 ohms. Right now we're at 1,000. So resistance-wise, it looks good. But what I want to do is kind of put it through its paces and see if we can get a good waveform. So to do that, I need to reconnect my air cleaner, and then we'll start the car. So give me a second to put that back on. All right, I got my air box back in. We're going to check. I'm going to fire this thing up, and we're going to check this waveform and see how it looks. Right now, we're going to have to change the volts per division. Shrink this up so we can see it. So there's our waveform. See if I can speed it up so we can actually see the waveforms a little bit better. See if we can trigger on this a little bit better. Guessing my car is sensing some type of vacuum leak because the air cleaner is not on perfectly. So you'll notice, and it's kind of tough to see, but when it settles down, the waveform settles down, you'll see that it's actually a little lower on the slope here. If I reverse these leads, the higher point should be first. It should go positive first. So let me see if we can do this. There we go. So you're seeing the positive waveform first. Sorry, there's a hell of a lot of glare out here today. Okay. So the waveform looks good. You can see our volts max is 2.7. The average is like 1.5 or so. So the sensor looks good. So maybe there's an intermittent connection at the connector, but I'm going to replace the cam sensor anyway. Here's my PCM, okay? There's 3 pins associated with the VR camshaft sensor. My CID1, CID2, and then my VR return, okay? So if you follow these, both of these sensors have a common pin that comes back and then goes into the PCM. That's going to be your return or your ground through the PCM. Again, this sensor generates an AC signal. So we just probed this pin here either on camshaft 1 or this one here on camshaft 2. And that's how we got that waveform that you just saw. So let's take these camshaft sensors out and then see what happens. Yeah. So not much metal. Not sure what this is. Could be, don't know, could be wear, but we definitely have moisture inside of this connection. And we have moisture down here. So we're gonna dry this out. I'm gonna put my new camshaft sensor in and we'll see how she functions, but this is definitely causing an issue. All right, so just for confirmation, here's my old camshaft sensor. Here's my new one. Here's the, this is from the service manual, service data. So this is a Taurus, it's a 2008. It's saying the minimum resistance 586 to 2K. Got my own meter connected. Gonna take a quick measurement. So we're just using these back probing pins. So old one, just about 1K, 1.1. Now keep in mind, if this was in the vehicle, this resistance is going to change again, just based on the position. So each time it swipes by, it detects it and changes. So let's take a look at the new one. Again, that was 1165. New one, pretty darn close. So probably don't need a camshaft sensor. I really think it was the moisture inside of the connector. So we're going to put this in the car and then we'll check the waveform again. And so it's about the same. Again, I really think it was the harness, moisture in the harness. Interesting. Notice our volts peak to peak. Now we're at 3, almost 4. Now we got 2 as an RMS. Interesting. Let's just flip this around to get our waveform going in the correct position. Yeah. Interesting. So it made a difference. Well, bad connection. But anyway, hey, if this video helped you, like or subscribe, really appreciate it. But I'm going to continue on. I'm going to film the rest of this video and replace the second one if anybody's interested. Hang around. Okay? Okay, so let's check this out again. Here's our old one we just took out. So that one's pretty good as well. So 1.2K, and just for reference, here's the one we're going to put in. We don't want to assume the parts we got from the store are good either. So this one's pretty close to what we've taken out and what we're going to put in. So 1.2K.